And the temperature is inferred from this deuterium to hydrogen ratio. All right, so what does that mean? Just for a second, let's just see what they're talking about here. All right, the deuterium to hydrogen ratio, what they do is they look at the water. And in any sample of an element, you know, there is some natural abundance of different isotopes. And for hydrogen, actually, the element hydrogen, 99.99% of elemental hydrogen is in the form of the isotope that we call H1. That particular isotope has no neutrons and just one proton. But 0.01% of the naturally occurring hydrogen in the world is deuterium. We call that H2. H2 has one neutron and one proton. All right, so because of this natural abundance, then any hydrogen that's found in any compound that contains hydrogen, 0.01% of that hydrogen is going to be in the form of deuterium. So in the oceans, for example, you know, there's a lot of water, so there's a lot of hydrogen. So, excuse me, most of the hydrogen is in the form of H1, but a very small percentage is in the form of deuterium. So what that tells you is that most water is just a regular old oxygen and regular old hydrogen. And so we'll just put ones up here just to indicate that we're talking about the isotope hydrogen 1. But a very small bit of the hydrogen in water is going to be deuterium, in the form of deuterium. And because the mass of deuterium is twice the mass of hydrogen, it has a mass number of 2 as opposed to 1, then water that has deuterium as its hydrogen is heavier. Okay, so you could call it heavy water. And what happens then is that, you know, in the oceans and the lakes and whatnot, where you have all this water, the water is evaporating. The lighter water is going to evaporate at a faster rate than the heavy water. But then, so too, the heavy water is going to condense faster than the lighter water. And so there is a correlation to do with temperature, evaporation, and condensation. And scientists have worked it out so that they can actually correlate the deuterium to hydrogen ratio in ice is going to change depending on what the temperature was at the time that the ice was formed. Now, in the Arctic, the ice was formed from snow. It fell in the form of precipitation, and then it packs down, and the snow changes into ice with pressure. So, we aren't going to understand completely how that's done. That would take like an hour to explain it. But the bottom line is that scientists, because they know the difference between deuterium and hydrogen, they know the abundance of deuterium, what it should be under completely natural conditions, they can then predict this ratio is going to change slightly depending on the temperature at which the water was evaporated and the water fell back to snow. That's how people can infer temperature from the deuterium to hydrogen ratio found in the ice, from the ice core. Okay, so there's legitimate science that can help people predict all the way back, 160,000 years ago, what the temperature was at the time that the snow was formed.